much for tuning in to today's Hacker Village episode. I'm Kathryn Mills. I'm a co-founder of Hacker Village, and it is our mission to bring open source, collaborative, hands-on Python coding skills, training, if you will, to the oilfield and energy sector. So today's class is run by my good friend Matt Bauer, who's also the other co-founder of Hacker Village, and our friend George will be the instructor, and they will be addressing the Pandas package. Now, this is important to everyone across the oilfield and energy sectors because Pandas allows you to import and begin to organize and manipulate your data so that you can understand the story of whatever project you are working on. It's a bit dense, but it's how you build that foundation. You can also go back and check out some of our older episodes, like that one right there, where we address the syntax of Python, which is the unique language of the Python coding itself, so that you can understand how all the bits, pieces, and parts all fit together so that you can begin, again, manipulating and utilizing your data in a more efficient and effective manner. Now, before I let Matt and George take over, if you could, go ahead and click that little subscribe button for me. That way you can get notified every time we load a new class or the Crude Audacity has an episode, or really just all things oil field. This is the place for it. And be sure to follow us on LinkedIn, individual pages, or the Crude Audacity Podcast page. That's where we make all of our announcements, but really it's about you. It's about getting you up to speed and giving you a new skill set for your tool belt in the oil field. And finally, if you can, go ahead and leave us some comments below. We love your feedback. What did you like? What do you want to learn more about? Is there a specific topic that you would like us to address? Now, I'm going to stop talking so you can jump into it with Matt and George, really get down to business. So grab a beer. Let's code.
Hey, folks. We're going to be getting going here in just a bit. My name is Matthew Bauer. I'm a geologist. We're here with 2M Energy up here in Golden, Colorado. I also been specializing in Python programming for the last few years, started in grad school. We're going to be opening up today with George, who's very graciously decided to share some of his Pandas knowledge with us as well. Tonight is actually, it's the first probably 2 sections, maybe 3 that George is going to do on Pandas. This is actually the second part, or the second episode, you could say, of Hackers Village, which is a educational program that me and Kathryn Mills of the Crude Audacity Podcast have been putting together. If you would please go on, we just got our YouTube channel set up for that. Let me get that link sent over to you. But if you go ahead and subscribe for that, and go ahead and get notifications on there, we'd appreciate that. A special thank you to RMAG, the Members in Transition Program, Crude Audacity Podcast, as mentioned before. Subscribe to her podcast and go ahead and tune in. She has a lot of event announcements for this program that we talk about. Also, Sarah Dudowski of CU's GEM program, Josh Sherskill of Churlick, Well Data Labs, and Jim Thorson from Free Radical Ventures. And also another special thank you for Terry Olson. Terry reached out to us and wanted to get involved with the Members in Transition program. And we thought that it'd be good to try to get that in because we're both trying to get educational materials out there for folks that don't have a paywall in the way of that. Let's go ahead. Yeah, so everybody, this is George. George is a production engineer. He also has a degree from Mines, which he did graduate with honors. But definitely check him out on LinkedIn. And he's a quick rising guy here, a young one with a lot of skills. But in the chat, if everybody kind of reach out and say where they're coming from, what part of the country and whatnot. Houston, Texas. Conifer, New York, a few more Houston, some more Colorado. Hey, Zach, how's it going?
Quite a bit of people from Denver, I see.
Yeah, that's great. Mexico City and Michael Hardy. Hey, Mark, how's it going? So we will be recording this and we will get that cleaned up a little bit and then post it out on YouTube. So if you want to go back and listen a little bit more of George's explanations on something or that kind of thing, or if you want to share this with somebody that wasn't available to attend tonight, we'll have that available. And we actually just did, just this last week, got my basic syntax, the 2-part series up. So, but on that note, I think everybody should grab a beverage of your choice, beer if you like, and let's do some coding. So George, I'll turn it over to you.
All right. Hey, everybody. My name is George Matevosyants. Before we kind of dive into it, I really want to say thank you for this opportunity to HACKERVILLAGE, Matt, and Kathryn. I realize right now is a more or less volatile time in the oil and gas industry, so hopefully you guys can take advantage of this opportunity and just have an extra thing in your resume and just have an extra skill to have. And I would say, as far as this is a very useful skill across all the industries. So as Matt said, all this is going to be on YouTube, so visit the YouTube channel, subscribe for the new updates on there as well. As I said, my name is George Matevosyants, and I am a graduate from Colorado School of Mines. I do have some prior coding experience. I got my electrical engineering from CU Denver, so coding has been pretty close to me. And with the nature of work that we're in, and oil and gas in general, we got a lot of data, so it was just kind of natural to kind of pick up Python and Pandas and just kind of roll with it. So it's been an extremely useful skill to have. The main reason I've picked out Python, really one of the main usages has been I've been looking over the LOE data, and there's a lot of scarce data, there's a lot of accounting and this and that, and really to wrap your hand around that and use Excel for that just gotten out of hand. Excel was not doing it. At some point, Spotfire is also becoming difficult to handle. So once you really go Python route, you're really not going to go back to anything else as long as you're comfortable with Python. So without further ado, Matt, if you're ready to dive into it, I am as well.
Yeah, let's dive, man.
All right. Let me know if it's visible, Matt.
Yep, absolutely, sir.
All right, so I'm going to be using Jupyter. There's a lot of IDEs for this, right? Plenty of them. There's Hydrogen, there's some other stuff. Jupyter has been the first thing I picked up, and it is a web-based IDE. So whatever you can code in HTML would also be coded the same way here. I do have everything that we're going to go over and extra under my GitHub account. I actually specifically created that for this class. You would see once you guys access my account, the link is here and also has been sent out. There's a bunch of other repositories that I've just forked from other people, and there, you can see there's 100 Pandas puzzles, there's Pandas exercises, data science handbook, etc., etc. Pandas intro is the one that I created myself when I was learning Pandas. So this is the core material that we're going to be using today and kind of going forward for the entire Pandas library. It's as easy as clone, download a zip file and whatnot, and you guys have access to that. I am going to assume that majority of people do have access to it. And with using Jupyter, once you guys download it, you are going to get a window similar to this. So just navigate to your project, whatever that may be, and then just pick the notebook that we're going to be going over. So the first one is going to be Python basics, right? I know Matt has gone over that, but I just want to go over a few things here and emphasize on a few things that will be used throughout the Pandas tutorial that we're going to go over here. So once you open that up, you'll see there's a bunch of links in here, right? I try to make that as user-friendly and informational as possible. You see there's Python, and there's a library within Python, there's a bunch of other things as well. Before we dive into it, right, I did post coding standards on here. It is suggested to use those. Once again, it's not required by any means. But a few things to emphasize, right? People don't normally use tabs in Python. If you're using Jupyter or any other IDE, clicking tab would correspond to actually 4 spaces in in Jupyter. So, but normally, you know, 4 indentations, 4 spaces will correspond to a, you know, function or a subcode within the parent code. Another thing is try to wrap the code. You do not want your line of code to be excessive going out of screen. And, you know, just make it easy to read. So spaces around operators such as like a equals to and function and whatnot. Once we get in within a function call, it is all right to not put in spaces right away. Just essentially the whole point is make it user friendly and easy to read. First thing is strings, right? I want to really review the strings and not in depth. Matt's covered all of that. So I'm just going to emphasize a few things that we are going to see throughout this tutorials. So first thing, right, the string, if we add them up, we're going to get a nice combined string. A plus B will give us a B string. If I do multiplication, right, we'll get A 3 times in a row. If I do AB times 3, I'll get an AB 3 times in a row. Important thing to note, if we are escaping special characters in a string, such as quote, right, we could see that quote is a special character. We got one here, and that is emphasizing the fact that it is a string. With anything inside of here, it would be a string. So if we do have a quote such as this one within a string, we do have to escape that. So special characters, you can look them up online, what they are, but they do have to be escaped. Additional thing here is if we want a string that spans over multiple lines, just put in a triple quote at the beginning. Anything within that and ending triple quote will be a 1 string. As you can see, when I'm printing that, I'm getting a single string here, and new line character gets added on additionally. So Matt, I can't see the questions coming in, so guys, ask questions as we go along if there's any. Same deal, I have a lot of examples here, right? You guys can follow that. I am escaping the new line character here, and that's why this string is different than the one above. The only difference here is I'm just escaping a new line character, and that is it, right? And then we'll run that, and we'll get this as basic string business. You'd see that. One thing to note, strings are immutable, right? They cannot be changed, but they can be sliced. As you can see, I defined S would equal to a string test, and I want to grab first 3 characters, right? I'm going to start at character 0. Get used to the fact that all the characters in the lists, they get iterated at 0 and then go on until the end of the string. So I'm going to start at character 0 and go up to 3, but excluding 3. So that would mean is 0, 1, and 2, right? So if I do that, I can slice a string, and I'm going to get TES. Now, as I mentioned, strings are immutable, right? So I cannot change a single character within a string. So if I'm going to go write a statement as such, S of 0, which means letter T, equals to 8, that is going to give me an error because, and it says in here, the string object does not support item assignment. That is pretty much all to the strings. Just escaping and multi-line comments is really what I'm after here. There's a few extensions you can install in Jupyter, and we can touch on that a bit later. I have one installed for collapsing the headers, so it's just easier to follow. And before we dive into the actual pandas, right, one more thing, data structures. Extremely important. Matt covered those. I'm just going to touch on the basics of what I want to emphasize on. So, you know, there's a few examples. That's how you would create a list. I would add 3 items in there, such as apple, banana, and cherry. And you can see they're all strings. So I'm just going to add 3 string items to it, and then, you know, if I print it, and all of a sudden I get apple, banana, and cherry here. String lists can be sliced in the same manner as strings. You'd see if I just pick a 0 item from there, I'll get apple. If I want to pick items 0 to 2, I'm going to grab items 0 and 1, which is apple and banana, excluding 2. Important to remember that because it is going to be the same behavior throughout the entire pandas. Strings and lists are different in terms of slicing. Well, I guess assigning variables as lists are not immutable. So where I could not change a letter in a string, I can't do that in a list. So I'm going to grab the first item within this list, and I'm just going to assign a new value to it. I'm just going to say, instead of apple, I want that to be a new value. And all of a sudden, you know, the first item in the list is going to be a new value here, as you guys can see. Another nice thing about lists is you can start from the end. Let's say I do not know how long the list is. Granted, there is a way to find that out. If I put a negative in front of the slice, it'll tell me that I'm going to start from the second to last character, or item, not character in this case. So I'm going to grab an ending cherry, right? If I'm not putting the ending to my slice, I'll grab everything at the end. Now, we can add a step size to that as well. So let's say we're going to start from a last item. We are going to go until the end, right? And the last item until the end technically is nothing. But when I define a step and I put a negative, that reverses the order. So what that implies is I'm going to start from the last item and I'm going to go on to the beginning because my step was a negative and my step size is 2. So therefore I'm going to skip and grab every other item starting from the end until the beginning of the list. So you can see now I'm grabbing cherry and new value, right? You would see that I went backwards. I started from here, skipped banana, and went to new value. There's some freelancing with the code, right? You guys feel free to follow that. There's a few functions you can call on the list, like length, append, etc., etc. One thing I'm emphasizing here is a list does not have to contain the same variable type. So I have a list 1 of ABC, and then list 2 would be D and number 2 and 3. When I add them up, I do get a final list that has 4 strings and 2 integers, which is nice, right? And then in a lot of other languages like C and C++, it would be more problematic. You would have to define the type of your list. So here in Pandas, it's very nice and convenient for us to do that. List comprehensions. So that one is the built-in capability and functionality of Python, extremely useful. I have been using it everywhere in my code, to be honest with you. What comprehensions mean is, the best case scenarios here. Let's say I create a list, an empty list of letters. I'm going to add a for loop, and I'm going to grab every letter of string George, and I'm going to append that letter to the list, right? So I'm going to get essentially a list, and every item in that list is going to be a letter of my name, for example, right? It just seems like there's too much code in here, right? And that is true. Python does let us do that a lot quicker. So here's the equivalent of this for loop in one line here. If you're putting in square brackets, right, at the beginning and the end, Python automatically knows that it will be a list. Whatever is inside of it will be a list, right? And then I'm just going to write a for loop inside of that. And I'm going to say, populate this list with L, where L is going to be a letter inside of George. So the same result, but a lot less code. You can see right away, in this particular example, will be going from 2 lines of code down to 1. But list comprehensions can get a lot more complex. As you can see on this example, I'm going to do a similar thing. I'm going to create a list as an output. I am going to grab Y, where Y is going to be numbers from 0 to 100. Now remember, 100 is not exclusive, so therefore from 0 to 99. But now I'm going to have if statements within this. So I'm going to say only add Y within this range if Y is divisible by 0 or by 2, and if Y is divisible by 5. Now, we all know math, right? It's the same thing as dividing by 10. I could have just written if Y is divisible by 10, but just to illustrate the point, I just wrote this code. And you can see when the for loop runs, I'm getting a list of values between 0 and 99 divisible by 10. You really start to get the feel for how powerful these comprehension lists really can be. I got another example here. I'm not really going to dive into that. I'm going to leave it up to you guys. Actually, I'm going to step back a little bit and say all these tutorials are really meant to provide you guys guidance. To really learn Pandas, you're going to have to grab these notebooks, follow along, and just start inserting code above and beyond everything you see here, and practice as you go along. That is the only way you can really learn Pandas. I learned it myself. That's literally what I've done. I went to Pandas documents, the official website, and I just went down the tutorials. And we'll touch on that on the next notebook. But this example over here, I'm just writing some code. The same thing. I got list comprehensions. I'm going to get even or odd. I'm doing some if statements here. I'm doing a for loop, and essentially, realistically, without list comprehensions, this would be a 5-6 lines of code, and I can combine and collapse it into one and get a list of even and odd. I have attached for you guys' convenience a screenshot of all the list methods. So anything you can call on the list, right? You can say, for example, here I would say object, and in Jupyter, another thing is it is a interactive Python, so IPython. Therefore, if I click tab, it will give me all possible methods that I can call on this object. Now let's say I'm going to click append, which is over here, right? Oops. Okay, and then when I open up the parentheses, if you guys are not sure what this function does, Alt tab at the same time will give you the definition. Unfortunately, this is one of the basic string functionalities, therefore there's not much documentation. But it will be used excessively in Pandas. So tab will be autocomplete for all of you guys' methods and functions that you can call an object, and then Alt tab once or twice will give you the actual definition. And that's really what's telling you how to drive your code going forward. Next on is tuple. As Matt touched on it last time, right? It's similar to a list. One thing that I want to emphasize on here is that it's immutable, so you cannot change that. You'll see it in a lot of Pandas functions and applications. The inputs to Pandas is going to be a tuple. And that is implying that you are certain that your inputs to the functions are not changed in the background, on the back end. You can see I'm just going to create a tuple. The only difference here is instead of square brackets, I'm just going to have a, round brackets over here, and that's pretty much it. Same deal, I can slice through it, I can select items, right? Nothing really much changed here. Just emphasizing the fact that it is immutable. You cannot change the items within the tuple, but you can add more to it. Another item is a set. I've not really personally used it as much in my code so far, but one popular list of sets is removing duplicates. So set is it's immutable, it is unordered, but you also right as immutable, you cannot change the items within it, but you can append to it. So if you got duplicates, it also removes duplicates for you. So if you convert a list to a set, your duplicates will be automatically removed, which is a nice feature to have, right? You don't have to write the code to remove the duplicates. Dictionaries, once again, just touching on it, there's a lot more code that I'm not going to cover here, just for the sake of time, because it's really not concentrated on this. But one thing I do want to emphasize is that the key is a collection of a key, or dictionary, sorry, is a collection of keys and values, right? So you will see this dictionary is the name of that dictionary, and the key values are going to be brand, model, and year, and the values corresponding to it are going to be Mustang in 1964. Now, the thing that I really want to emphasize on is the way you access the values within a dictionary will be as such. You would say this dictionary, you open up your square brackets, right? And you provide the key name. Once I provide the key name, you're going to get the value corresponded to that. So you can see I'm printing this dictionary, I'm giving it a key name of a model, and I'm expecting that to print a Mustang for me. And you can see that I'm printing that. You can also use some other methods assigned, to dictionaries such as get. So if you provide a key value to that, then the value of Mustang would also get up from that. So just the thing to emphasize, square brackets, providing a key will really give you the value of that key, right? Looking through a dictionary, once again, this is for you guys to really explore. Not much in there that you're going to be actually using in Pandas, but it's really good to know, because at some point in your coding experience, you will be using dictionaries. Dictionaries can also be composed of actually other dictionaries. You can see I have my family dictionary, and that consists of 3 dictionaries within a dictionary. It's getting quite wild here, so once again, really up to you guys. I'm leaving it out here, and I'm providing you guys the tool to really try it out. Control flow tools. So that one is important. I have a URL here. If you click on that, it'll take you to Python version 3 tutorials on that. It's an official documentation, shows, really useful and a ton of examples there. One thing to note is just the general syntax here, right? You're gonna have if statement, you're gonna have some Boolean expression saying X is less than 0. As long as the value is true or false, that's all we're after. Python's gonna be happy with that, right? You can say else if, or elif in this case, or else at the end of that if statement. I'm not gonna concentrate on this, just bringing it out here. One thing I do want to emphasize, Python, just like in for loops and list comprehensions, does allow you to do a one-line if statement. You can see that over here. I said price equals to 10. Here you go. Here's my mess up. I'm forgetting to put spaces myself. I'm saying X equals expensive if price is greater than 20. Else, X is going to be cheap. So you automatically see, right, that this and this is taking up, 7 lines of code. Here I'm just going to do 1 line of code and I'm done. Right? A lot easier to read, a lot less code to type. And that's kind of what we're after. If statements, just like comprehension lists, can get quite complex. You can say expensive if price is greater than 20. Else, it's manageable if price is greater than 10. And if it's outside of 10 range, below 10, then I'm going to pretty cheap. So all of a sudden, comparing these two codes, you can see I went from that to that, right? Really powerful, really useful here. For loops, I'm going to just kind of run through it, right? I got a list. The main concept here is for whatever item I name it here, W in a list, words, right? My list is going to consist of cat, window, and that demonstrate. I'm not even sure I got that one online, to be honest with you. So let's just roll with it. So I'm just going to say for W item inside of this list, right? I'm just going to grab one and I'm going to do stuff to it. In this case, I'm just printing the actual word and I'm printing the length of it. As simple as that, right? Now combining for loops, if statements, just want you guys to get used to it. That's all it is. I'm just putting it here. It's going to be used throughout your code. Really play around with it, explore it. Another thing is range, right? Let's say I have a list and I don't know how long it is, or not how long it is, but let's say I want to go from 0 to 5. I do not want to create a list with values of 0, 1, 2, 3, 4, right? I can just say range, give it a max of 5. Once again, we are going to stop one value before 5. So it's going to say for range of 5 items, and the item is going to start at 0 and going to go up to 4. Just print actual items, and I'm just printing 0, 1, 2, 3, 4. Same deal here. The only difference is I'm defining a start, a finish to my range, and a step size. Once again, right, you guys can see the similarity we've seen between slicing between the list and the strings. I always provide a start, I always provide a end, and if I do want to provide a step, I can do that as well. So the same deal here. Now I'm going to print 0, 2, 4, 6, 8, excluding 10. While loop. All right, so I have seen people struggle with this one. In particular, my wife, I would say, when she was first learning coding, her first question was like, well, what is the difference between the for loop and the while loop? And it was really hard for me to explain, and really the best way to describe it is if you do not know how many times you're going to do your code, just write a while loop, right? While loop is controlled by your Boolean here. So let's say I have number 5. Then I'm going to keep squaring it until I'm going to get to 1,000,000. God knows how many times I'm going to do it, right? I have no idea. I'm just going to keep doing it until I reach 1,000,000. Without me doing crazy math to determine how many times I have to do it, there's no way I can write a for loop. So I'm just going to say while number is less than 1,000,000, print the number itself and square it. And you can see I'm not defining how many times I'm going to do the loop. I just keep squaring it, and as soon as the number becomes greater than 1,000,000, stop, exit. That's all to that. Functions. Okay, so that one's going to be quite complex. A lot of documentation here. I'm going to touch on a few things. Main thing is if you put in a key code of def for definition or defining a function name, whichever name you want to name your function, and providing input values and a semicolon, you are good to go. Whatever code is in here, as long as it's indented, it's going to be within the function definition. I have a lot of definitions. Once again, it's coming straight from Python documentation. Feel free, the link is up at the top here to really dive into that. One thing to note, you guys have seen, all right, I'm going to write some code here. For example, A equals hello, right? So it is a string. For me to get autocomplete, I'm going to have to run that, and I'm going to say A, and I can pull up it wants to get the methods that are associated with a string. Let's say I want to do capitalize. When I want to pull up without tab the definition of a function, this doc string right here is defined within the function capitalized. What I'm getting at, let's say I'm going to define Fibonacci series, right? It's going to be my function. I'm going to say def define, name the function Fibonacci, and my input is going to be n. The first string that's going to be right below this function definition is going to be the same doc string that you've seen here. All right, this guy right here. And I'm going to show you guys an example of that. So let's say I run that, I created a function Fibonacci, and now I want to run it. So I now want to run the function, I'm going to click Alt Tab, and you can see the autocomplete automatically pulls in the exact same string I typed in here. So this is really for bookkeeping. If you guys are writing functions to not get lost on what they mean and what they do, define it right after the definition of the function. And it will get pulled up in IPython as a doc string right over here. You would see me utilizing that up and down and all over the place with Pandas. That is the only way I would really run Pandas, just using that. Arguments, when you define a function, as I mentioned earlier, you need to pass in arguments such as, prompt or whatever else. I have some interesting code in here. Great. One thing I want to emphasize is you can default your inputs to your function. Let's say if somebody calls my function ask OK, they can pass in the prompt, but they do not have to pass in retries. If they do not, my default value is 4. If they do, it'll get overridden. Really important to know. Once again, once you pull up Pandas, you see it all over the place. There's additional information here in terms of the variables within the function. They could be positional, they could be keyword and positional, or keyword only. Honestly, too much for the first class. I'm just going to let you guys explore and read that and really get into it. You would see, for example, like I have a definition of function parent. I have voltage, state, or I have some action here and some type. I can call that function with just saying 1,000. It would know automatically it's the first variable, voltage. I can say paired voltage equals 1,000. Python will recognize that. I can say paired voltage equals 1,000. And now I cannot action. I don't want action to be boom. I want it to be emphasized. For example, if I pass that in, all of a sudden you will see the output of this. No, it's not. Man, there's a lot of stuff over here. It's going to print a ton of this. There we go. So you will see the first call I made, I did not override action. Boom. Right? So you will see it's not capitalized. Second time I call the function, it's emphasized, there's capitalized letters, and all of a sudden it gets overridden, and I'm overriding the default value. All it is. Nothing extra to it. Suggest that was extremely helpful for you guys to really dive into that once again. Unpacking argument list. Honestly, for the sake of time, I am going to skip this one. I'll let you guys kind of dive into that. It's not really the main concern. So, but it is once again useful to know. I would save a lot of code for you guys. Lambda expressions. Let's say you guys want to run some code and you do not want to define a function. I just want to write a function real quick and not give it a name. I just want Python to know that it is a function. The way to do that would be using lambda expression. So lambda x semicolon, x plus n will be a function within itself. And x will be the input to that function. I'm not going to blow you guys' mind with that, honestly. Once we get into pandas, it'll be pretty obvious there. So with that, this is kind of the Python basics are kind of done. Matt, are there any questions? What's it looking like?
No questions so far. There's a couple of tidbits I even picked up out of that. So it's good to see other folks code. So
good. I'm not going to change that. Okay. So now we're really going to dive into pandas. All right. So I'm going to import two libraries. Matt's kind of touched on them, right? NumPy stands for numeric Python, really concentrated on linear algebra and matrix operations. The entire pandas is based on that. It's not necessary to know by any means to use pandas. A great library to know, one of the basic ones. All the pandas documentation can be found on this link. The way I learned it and the way I'm suggesting you guys to learn it, and that's really what I found online, is go to that documentation. There's going to be on the left, there's going to be 4 categories that just touch on what you can do with pandas and give you kind of an intro. And then once you get done with the intro, go to the user guide, and then it will give you topic by topic and examples and explanations. And that's exactly the same way I structured my notebooks. You'll see, like, number 1, basic functionality. I'm really giving you guys a taste of what it can do. Number 2 will be number 2, multi-indexing. So I'm indexing and selecting data. So I'm diving straight into here. Input-output tools. There's not much there. You guys explore for yourself as necessary. But number 3 notebook will be multi-index, advanced indexing. You see, I'm following now to a T almost, the first 5 or 6 categories. So follow my notebook, follow the documentation on pandas, and you'll be just fine. All right, so diving into that, now we're really concentrating on pandas, right? So everything we'll kind of reviewed up to this point will be explicitly used in here. First thing, I just want to cover data structures. So series is the first data structure that pandas has. And series, think of it as states over here, it's like a one-dimensional array, labeled array capable of holding data types. Essentially, it is a column. Imagine that being a column, right? It is an array or a column that can hold any data type, and it has an index. An index will correspond to a row label. So every row within that column would have a label. So kind of like dictionaries, right? And that was the main thing why I decided to cover dictionaries. You guys feel free to read all the documentation. Once again, I strongly suggest to read it. Here, I'm just creating a panda series, and I import a pandas as PD. So if I am going to use the library, I'm just going to say pd.series, and I'll tell pandas that I am creating a series, which in this case would be a column. Don't concentrate on this code. I'm just calling NumPy, and I'm generating random numbers. All that means is I'm going to generate 5 random numbers of random distribution with a mean of 0. That's it. I just want 5 random numbers. And you can see right here, I am saying index equals, and here I need to provide a list, right, or anything that would define row labels. And now we are going to go to autocomplete option. You would see that if I click Alt-Tab, all of a sudden I get my definition. This is a doc string right here, the one I've been showing you guys. It tells you everything about the function, about the method. And you can see parameters, right? The first one is data. Oh, you can see here that they are defining defaults. So if you're not providing anything, it will be equal to none. So data, index, data type, name, copy, etc., etc. If you scroll down, you can see what they mean. Parameter, first one's data. It says array-like, iterable, dictionary, scale value, anything that can be converted to essentially a list or something that can be put together as a list. Index, that would be the row labels. It says array-like, just like the previous one. That would be a list equivalent, if you would, of what the row names or numbers would be. Data type, once again, it says optional. You do not have to provide that. If you don't, Python would automatically determine what that is, right? So In here, I'm just using the first two, right? Once again, data, I'm providing data and I'm providing index. In this case, I'm specifying this as an index. So I'm saying it's going to be 5 random numbers of random distribution, and I'm going to name them A, B, C, D, E. So all of a sudden I get this column, right, or a series, if you would. These are the 5 values, and these are the indices for those 5 rows, A, B, C, D, E. And the data type of that will be a float, right? So you can create that. You can create a series from a dictionary if you want. Realistically, from my experiences, very rarely would you be creating a series. You're going to be reading in a table, then you're going to just automatically convert that to Pandas data frame, which will, I'll get into all that. But there's multiple ways, right? As you can see in here, in definition, we said we can create it from an array like iterable or dictionary. So this time I'm providing Pandas a dictionary. The key pairs would be A, B, and C, and values would be 0, 1, 2. Are there any questions, Matt?
Yeah, I'm answering some of them.
Okay, cool. So you'll see the labels for the rows are A, B, C. The values are 0, 1, 2, right? So really utilize these definitions, especially if you're using IPython, interactive Python. Dive into that, read. All that is provided for us here. It'll make your life a lot easier. So I'm just going to run that, create a series. In this case, let's say I am providing a dictionary again, right? And dictionary would imply that values of 0, 1, 2 should have labels or indices of A, B, C. But now, so I want to expand it. I want it to have A, B, C, D, E. What is it going to do? It'll create a series for me, just like I did before. But now that I'm explicitly providing an indices to Pandas, it'll create the last two to fulfill my indices needs, D and E. It will not have a value. NaN corresponds to not a number in Pandas. So since I didn't give it a value, it will just create a row with no value in it. All right. I can also provide just a single number, 4, and then I can give it a rows, A, B, C, D, and then Pandas will automatically fill in all the rows with the value 4. You guys can see that over here. Let's see what we're doing here. Okay, so now we're going to get into accessing actual values within the series. All this does is it just sees my random number generator. So every time I do this statement right here, where I'm generating a random number, it'll generate the same list. As you would see right now, let's do that. Let me comment this out. I'm going to run it. Oh, I should probably print that first. I'm going to run it. It'll be 8837. Right? I'm going to run it again. It'll be the same value as 8837. Now, if I comment the seeding out, I get different numbers every time I run the code. It's really nice to debug your code, to see the random number generator. So I'm just generating, once again, random integer values from, 0, random integer. So it'll be low, starting at 0, right? At this point, I can't recall what, what's happened there. Okay, at this one I can't recall what this function does, for example, right? So I'll just do, once again, my autocomplete. I'll tab and it'll tell me the first will be the low, start at 0, go up to 10, size would be 5. So I'm generating numbers from 0 to 10, and I want 5 of those numbers. That's all that means. And the row labels are A, B, C, D, E. So you can see the same view here. Now the whole point of that code was to access the values. The values within Pandas can be accessed similar to a dictionary. Remember, you pass in a key from a dictionary, you're going to get a value corresponding to that key. So I'm going to pass in an index A. So I want row A within that column or Pandas series, and I want a value for that. And all of a sudden I get 8. I can provide a actual integer position right? So I want first value, not 0, but first, remember that, from a Panda series, and that'll be value 8. And as we recall, our series looks as following. So if I want number 3, I'm just going to change that to 2, and we're going to get 3. You can check the data types within a series. It's as simple as that. You'll do S. Let's say I do not know what I can do with a series. Click Tab, and you'll get every single method that you can access within the Panda series. So if I click S.dtype, right, it'll give me data types within the Panda series S. And it tells me that those are all integers, 32. When working, so okay, so there's really no need. You can loop through the series and Pandas data frame. If you find yourself in a position where you got to loop through it, you're probably doing something wrong. Realistically, that's the answer. You do not want to be looping through it. There is everything we can think of has been done, and all the hard work has been done for us. Let's say I want to add, for reference, we got S. I want to add S twice, for example. I'm going to get naturally, like we had before, 8 plus 8, 8 plus 8, 3 plus 3, 7 plus 7. Right? So I'm getting these values over here. I can also multiply the whole series by 3, and I'm going to get some results, right? Nothing crazy, stuff that we expect as usual. Another thing that I have capitalized on was list slicing, right? Let's say I want to, same deal applies to Pandas. I want to slice that series. I want to grab the first element, not 0, but first, and go all the way to the end. And I'll grab everything from here down to E. Now let's say I want to grab last element, right? I'll go everything up, first element down, or 0th element, if you would, down to last, excluding last element, right? So I'm grabbing everything here, simply because I put -1. That means do not grab the last element, just go to the end. Nicely done in Pandas and in general NumPy as well. Anything that we do in terms of adding series, tables, arrays, the math will align your indices. So let's say I'm going to grab this guy and I want to add this guy to it. Before Pandas will add them up, it will match up the indices. So match A to A in this one. And there isn't one. And therefore I'm going to get not a number. B from this is going to get added to B in this guy. So I'll get 16. I'll get 6 because I got the C row in here. I got a C in here. And then D indices will line out because I have them in both elements, right? I got it in this series and in that one. The one important thing, really important to note, it will mess you up if you guys are not comfortable with it. Before you do the math, anything that Panda does, it will align your data based on the indices. It will match the row indices and then do the math correspondingly. You can see here in this case scenario, I got 4 values here, I got 4 values here, but only 3 of them match across both tables. And those are the values that are going to get added. Now data frame, this is the legitimately workhorse of Pandas. It is, imagine that being like a spreadsheet table that consists of Panda series. So it's just a table consisting of these columns that we have looked at before. That's all it is to it. It is extremely powerful. You can create that, you can create a data frame with dictionaries, just like we have seen before. Let's say I'm going to have a dictionary with a key of 1 and values corresponding to that key is going to be a Panda series. And that Panda series, you can see that all of that is within Panda series. Right? So I'm defining a column. The key for that column is going to be 1. The values are going to be a column with value of 1, 2, 3, and the row labels of A, B, C. Then I'm going to get a second key named 2, and the values within that key are going to be 1, 2, 3, 4, the corresponding indices A, B, C, D. You would see that right here. right? All I did, I created 2 dictionaries. I did not do anything crazy. I can pass dictionaries to a data frame to create a data frame, just like I did with series. I gave it indices, I gave it values and column names, right? This will correspond to a column name, and this will correspond to indices. When I do that, you would see that, oh, there we go. You would see that now I'm having a column 1, column 2, indices A, B, C, D, and the values that I have provided for it. Once again, very rarely you guys will find yourself having to create an actual table. Most of the time you have to just read it in and go through it. There's a lot more examples of creating data frames. I'll skim through them, right? I'm not going to get into details. One thing I want to emphasize here is you'll see that it gets pretty wild. I got nested table with a column A, subcolumns of these. I got column B, subcolumns of A, B. I got row A, and that includes rows B, C, and D. It gets really wild. Throughout these notebooks, I have created this shortcut for you guys for the functions that I would suggest, kind of summarize in the section and suggest practicing. Once again, if you guys look at the Pandas intro, I have a functions doc file that would have all the main functions in there. I would suggest looking at that once you're done practicing and really going over that list and making sure you're comfortable with all those. Attributes. Okay, so I'm just going to create a table df. Oh, there you go. Look at me. Creating values here, some values, right? What I'm going to do is I'm going to print that df. You see, I just created a table with column A, B, C, row indices 1, 2, 3, 4, and here's some random values inside of that. The attribute I can call on a data frame are similar to the ones within a Pandas series, right? So I can say D types, and it'll tell me what kind of data types I have within each column, and it tells me they're all floats. I can call in info, which is a method done for us, and it'll describe the table for me. It'll say my range index, so my indices. There's 4 of them. They'll start from 1, they'll end at 4. There's columns, there's 3 total columns, and they are column A, B, C. There's 4 values that are not null, and they're all float. Very nice, very handy, all done for us. I can even call function describe on my table. What I'll do is literally describe every column in here. You don't have to do any calculations, any statistical summary for it. There's something done for us. I hope you guys are starting to really feel the power of Pandas in here. You'll see that A count of 4 values, the mean, the standard deviation for that column, 25th percentile, 50th, 70th, etc., etc. If I want to find out what columns there are, I'm just going to say data frame dot columns. Note the difference. I have brackets here. That means it's a method, and if there's no brackets, that means it's an attribute. So that just tells me the columns are A, B, C within that table. If I want to look at indices, which are rows, I'm just going to call that. And it'll say that my indices or rows start at 1. They stop at 5, once again excluding 5. And step of 1 is what we are incrementing by. None of that is super important right now. Out of everything we've seen, you guys have to just kind of practice and know these things. Everything you're going to see below, I'm going to have a notebook separately for that. Look at that. List comprehension. Similar thing we've seen before. Let's say I want to look at my table, DF. I want to rename my columns. I want them to be emphasized or capitalized in that case. I'm going to write a comprehension list code, right? So I'm going to say I want X, and I want to capitalize that. And my X is going to be a for loop for X in DF columns. Remember, the columns was this guy, which is simply an array that contains A, B, and C. And I'm going to say, grab every single one of them, capitalize it, and that will create a list for me. And I'm going to say df columns equals that list. And all I'm doing is creating that list as I go along. And now you can see that I'm printing that same table. If I do not print that, all I did was just capitalize letters in here. It was as simple as that. One line of code utilizing list comprehensions. I can slice it just like I have done in the list. I do not suggest using that throughout. You guys will see why. But it is possible to do it just like in the list. Yes, I want to grab a first row or 0th row in that case. And I want to go to row index number 2, which means row 0, row 1 in terms of indices, not the actual index number. That could be A, B, C as far as my concern, right? All I'm slicing here is 0th and first element. I'm grabbing that. I can grab my columns as long as I provide those as a list. So I want to grab column A and B. I can do that. Once again, do not constrain this. We'll get into depth for all that. I can convert my indices to array, right, in case you want to do some other calculations. All it is just grab your indices, dot array, or convert that to array. Not so important, just out there for you guys to practice. Once again, what I'm emphasizing on here is these. As long as you guys grasp onto that, you'll be all right in this notebook. Now, let's see. Creating some data frame. I mean, Matt, do you want me to delve into that? I don't think it's worth it, to be honest, for the sake of time. And
you can run through and just say what you're doing there.
Yeah, let's do that. For me to do that, let me run code. Okay. So I'm just creating a data frame here. Right, the name of the columns is 1, 2, 3. Don't be too concerned about that. Once you guys get a little practice, you'll be really comfortable with that. All I'm doing here in this code, once I have the data frame, is I'm going to grab the data frame, the actual data frame. I'm going to do some function ilog, which is for integer location of 1. Right, all that means is I'm grabbing this row. We'll get into details of that on the next notebook once again. Let's say I grabbed a row, I grabbed a column 2. How I'm selecting those, we'll get into a bit later. But you can subtract, which is done very nicely. Let's say I want to subtract a row 2 out of every row within that data frame. So I'm going to say data frame, which is this guy, dot sub, which is subtract, naturally. Get subtraction of data frame and other element wise. Definition is for you guys. First thing I need to do is provide a value or an array that I want to subtract. Then I'm providing it the axes. So one common thing within Pandas you guys will see is definition of the axes. All that tells Pandas is, how do you want to subtract? Do I want to subtract that array across the columns, or do I want to subtract it across the rows? When I put axes equals 1, that corresponds to columns. Let's split this code into 2 so you guys can see, and I'm going to print row because that's what I'm subtracting. You can see my row corresponds to a series, just like I've seen before. And the values are going to be these, right? So I'm just grabbing this column right here, or so this row right here. 1, 2, 3. And the indices of that is going to be the column names, 1, 2, and 3, right? That's all that means. Now, if I'm going to subtract that, what Pandas is going to do, as I mentioned earlier, it will align my indices. So it's going to have to align 1, 2, and 3 somewhere on this data frame. And I'm just telling it, align it for the columns. Axis 1 corresponds across the columns. So if I'm saying axis equals 1, that means grab this values, align 1, 2, and 3 indices across these columns, and then subtract. And that's why we get these new values, and you'll see that this row right here is zeros across. This is what we would expect, right? Because that's what we grabbed to begin with. Now let's say I want to subtract a column 2 from the entire table. For the simplicity, for visualization, here's our DF. And then as you can see, my column, I grabbed column 2. So I grabbed this guy right here. And you would see that I'm just subtracting a column, but now I'm emphasizing axes equals 1. That means whatever indices are within the column, I'll line them across my rows. And just for great visualization purposes, simplicity, you would see that my column, and I can name it X. Do not get stuck on the name of that. That's just a variable name. And I'm getting indices A, B, C, D. So Pandas would have to align, right, the indices from this guy to the indices in this table. For it to align correctly, it would have to be going across the rows. Therefore, axis equals to 0. All right. There's a multi-index. I'm going to dive into that in depth later. Or it's showing me that I can combine rows, kind of like grouping in Excel, right? I can have first level of rows. Within that, I have row A and B. I have some columns here. I have, once again, first level of rows of 1, and then they'll contain rows C and D. I'm just showing what capabilities are out there. You can get the level values of that, right? I'm saying grab level 0, which means grab this guy, and give me unique values from there, and return the list. So return 0 and 1. Once again, we'll dive into details of that. Not much to really learn here, and just really giving you guys exposure, just what you can do. You can simply replace missing data within a data frame, right? We'll just do df replace, df fill NA. They'll replace some values. We can drop some levels. Okay, so I just created a data frame. I copied the data frame, and just for the simplicity of that, I'll print it. So here's my df. I have column 1, 2, 3. My row names are second, right? It's just the name of the rows. But the actual row indices are A, B, C, D. I'm just copying that into the df2, data frame 2. Yeah. Well, it's not going to work now because I already dropped a level. But we can do that here. Okay. And below that, we'll do df2. So identical table. All I have done to copy a table is just do df that copy. Once again, we'll get to the depth of that. And you can see I have empty values. For me to replace them, it's as simple as that. I would say df2 replace empty values with number 10. And place means do not create a copy. We'll get into depths of that as well. Now let me just print df2 so you guys can see. So all I have to do is just write this, and then we'll grab every single empty value within this table and replace it with 10. Simple enough. Right now, what I'm going to do is, let's say I want to add data frame and data frame 2, now that I have replaced 10 here. And I'm going to fill the empty values with value of 10. You see the data frame 1 has 0 here, empty values. For me to add without this being an empty value, I'll have to fill in data frame 1 values, right? So I'm going to do that, run the code, and now all of a sudden I'm adding this table and that one. But before the addition happens, I'm replacing the empty values with 10. You're seeing the sum of those two right here will be 20. All right. I'll take a little sip here. How are the questions coming along, man?
Oh, we're good right now.
I hope it's not because the people are totally lost, man.
No, you're showing a lot of the things that you can actually do with this, and it's important to have this in your background as you move along, because you'll run into problems, and in order to make something that is a little bit more of a complex solution, you got to know your basics behind it. So maybe a little dry, but it's important to know. So
yeah, I mean, we'll accelerate through this. We'll get into those. Let me see what else is here. I mean, honestly, not at this point. Let me just cover this section.
okay, descriptive statistics.
Yeah, so all that stuff, once again, the hard work is done for us. Let's say I have like a data frame, and I want to find a mean. Once again, if you expand that, it tells me the first variable that I can pass it is axes. Remember, 0 will be rows, but if I'm doing congregation, so I'm combining the rows, that would be a mean for every column, right? Because I'm collapsing the table across the rows. So I've put a df mean of 0 means collapse these columns and find the mean for me, right? So all it does is collapses across the rows and gives me the mean for every column. As simple as that. You guys could see that it could be a lot more problematic in Excel, right? Doing the same deal here, and I'm providing 1, so I'm just finding the mean, collapsing columns. And now we can mean. Sum, same deal, df.sum. If you guys aren't sure, because you'd see over here I'm providing 0 and 1 for axes. You see the axes here, right? The initial value would be, the default value would be of 0. So it's just gonna give me a sum for every column. df.sum will give me a sum for every column. Now I can do that. I can say df find the sum, but skip NAs, right? Before it skips not a number value. So anything that's empty, it skips those values. That's default behavior. If I said now I want to skip it, I can just say skip NA, and I'm going to set that to false. If you want to find out if you can do that at all, you'll see that the second variable I can pass to this function is skip NA. I know it's very dry right now, but we're getting to the important part. We're getting to the fun part. Mean, I'm just going to provide some axes. I'm going to find some. Oh, there you go. That one's pretty cool. So let's say I have a table df. It looks as such, right? I'm going to do df. That sub means I want to subtract something from it. What I'm doing here is I'm finding a mean across every single column, right? What I'm going to do is I'm going to find the mean across every single column, and I'm going to subtract that mean from every row. So I'm going to find that mean, right, of these 3 values, and I'm going to subtract from every single one of these. Very cool, very simple, right? I just took the mean of every row and subtracted from every single value of that row. Just as simple as that. All right, so in here I just filled in the values that were empty. I have 2 empty values. I'm going to say grab those empty values. How I'm getting these values I'll show later. And I'm going to say set them to 100. Simple as that. I replaced all the values. Imagine you have a table with 1,000,000 rows and you just have no idea how many 0 or empty values there are. You don't have to know. You just do that code, boom, everything's filled in. Describe, there's a function describe. All it does is grabs every column and describes, once again, similar things. How many values there are, what's the mean, standard deviation, etc., etc. I can define my own percentiles if I want to. Defaults are 25, 50, and 75. I can set percentiles, 0.2, 0.5, 0.75. Correspondingly, you guys see I'm just changing that. I can change a data type of a column. Let's say I'm going to grab column A, and I'm going to set that as type string. So I'm just going to do that, and then all of a sudden, boom, D types. You see that column A is not a number anymore, it's a string. There's some other functions for mapping. One thing that we'll cover that later. ID X max would give us the max value within that column. Once again, the documentation is all there for you guys. Value counts, I'm using that one. That actually will grab, let's say I'm grabbing B. Let's do that. That's too much. What that will do is I'm going to grab data frame, so my table. I'm going to grab column B, and I just want to see how many values, what's the count for each value within column B. So it's very useful if you have a string column. Let's say you have lease area, and you want to see how many wells there are for that lease area. All you got to do is, for example, grab a table, say dot lease area column, and you're going to say value counts, right? And it'll tell you for this lease area, that's how many value counts there are. There's some binning functions if you guys want to do bar charts and whatnot. You know, we're going to get into that later. There's some functions that we can apply to that table. I would say that none of that is necessary to cover right now, to be completely honest. Reindexing, we'll get to that on the next notebook. Sorting, okay, that'll be nice. So you can sort by index, you can sort by values. Let's say The code is going to be different than what you guys look at because it's a different data frame. But let's say I have this big data frame and I want to sort that data frame by column A. It is going to be as simple as, that's going to do that. Let's say I want to do that. I'll do sort values, right? And I'm going to say I want to sort by A. And all of a sudden sort by A. Wait, what? Oops. Huh. Let's check this by. We'll do by A. We'll do axes equals 1. No. Interesting. Check for duplicates. All right, well, we'll have to figure that out later. But for the sake of time, I'm just going to skip that one. But essentially, you can sort by index. Yeah, sort. You can sort by. I mean, legitimately anything. It's really up to you guys what you can do with that. Just try out these functions and see what happens there. Honestly, you can do n smallest. They'll grab you the however many smallest values within that column. If you want just 5 smallest values, put in 5 in here. It'll give you that. If you want 5 largest values, it'll do that. If you want to sort values by some columns, you can type in sort values, give it a column name, we'll do all that. We'll really get into all that later. And you can see I'm doing some data frame, column A, grab me the smallest 3 values, it'll do that. So, I mean, in terms of exposure, I think that's just really kind of it at this moment, Matt.
Okay, let me share my screen. So this is actually an example from the course that I teach, Introductory Applied Python with RMag and Mines. But we'll go ahead and we're going to import our matplotlib library. And this is actually pulling in core data from the USGS Core Research Center. So we import that. We're using read CSV. We can take a look and preview our data. He'll talk a little bit more about indexing, so I'm not going to go into that too much. But then easily, you know, in just a couple lines, we can look at where the cores are located within that. And we can also plot that really easily. We can do some clay typing. So this is pulling in some data that I pre-exported from a LAS log. We'll calculate our clean and our shale zones. We're going to maximize. Let me get these off here. We'll take and we'll write up a function, read that in, and then we can apply that function and we can get that in there. And then this is going in using matplotlib. And then what we can do is when we can actually color our V shale on that graph of our ratio of potassium and thorium. But this kind of shows you, highlights some of the things that you can do with it. This is another good one. This is maturity data in North Dakota. So we can pull that in, and one of the things that, so I'm going to clean up just a touch here. Samples isn't in this one. I wasn't planning on running this today. But what I was going to highlight with this is that Pandas can allow you to merge multiple data sets that you would have to do like a VLOOKUP on normally. And it can be a little tough to do in Excel. So let's see here. What did it say? The name samples. Oh, that's why I didn't read this stuff in. Did I? Yeah. But anyways, that's a couple of real world examples of stuff that you can do with it and some of the power that you can do that in comparison with Excel, which a lot of times it requires manual manipulation or line by line of copying a formula through there, you can do very quickly. It allows you also to open up multiple file types that you can't do in Excel. You can open up much larger files. Those are some couple benefits of using Pandas. Hey, George.
Oh, you guys are.
Yeah.
Let me share the screen. Okay, now we're gonna get to the fun part. We're getting into slicing. All right, so the main functions are here. Once again, you can access the columns, you can access the indices, you can get the info for a table, right? You can print the head, which would correspond to the first 5 rows or however many rows you pass it. You can find out the data types on every column. You can change the column type, and you can just describe the table. You'll see that I will be going through it, and there's going to be some practicing in here. I got the definition of functions here, just kind of shortcuts for you guys. Once again, whether it's a series or a data frame, you can call a method or function, if you would, .lock or location. And if you pass it an actual string location or like a string name of the column or indice, they'll get you that back. iLock stands for integer location. So instead of passing column A, B, or C, I'm going to pass it column number 0, and it'll grab the same deal, right? Instead of using actual label, I'm going to use the integer location of that column. I can access that by a column as an attribute. I'll just say data frame dot A will correspond to an attribute column as A. You can do some advanced filtering accessing the data. If you do want to get just a simple integer value of certain cell, you just do I@, so integer at, you give it an integer position, and it'll give you just that one value, right? So once again, everything is over here for you guys for documentation purposes, out there to read. The links are on the first notebook. And now we're getting into the fun part. Let's say I'm going to write the code. I'm going to create dates, right? It'll be just a date range. Pandas creates that for us. That is for a later date. Just take it as it is, as given. But just quick peek over here. I'm going to start at January 1st, 2020, and I'm going to get it 8 periods, which means if I'm not specifying what period that is, it'll correspond to 8 days. All it is, I just created dates, right? Now I'm going to create a table for our exercises. You will see that I'm defining a data frame over here. Pandas, that data frame defines a table. I'm going to create some values. I'm going to create those out of a normal distribution, random normal distribution. And the size of that is going to be 8 by 4. So you can see I have 4 columns, 8 rows. And indices are going to be, we'll do that, equal to dates, which is this guy, right? And that's what I'm showing over here. And my columns are going to be A, B, C, D. If I run this code, we got to import the pandas first. All right. So now I'm going to run this code. And all of a sudden I get this table, right? Every time I'm going to run it will be different once again because I did not seed the random number generator. So if you guys are debugging your code, just seed that. Just reviewing some of the things, right? If I do data frame, which is the name of my table, that info will give me the information about that table. If I do describe, it will describe that table for me statistically. If I do dot head, it'll print the first 3 rows. If I do tail, it'll print the last 9 columns, whatever the number is here. I'll pass it to, it'll print the last 2 rows for me. Once again, the sum, right? If I do sum axis equals 1, it'll collapse the columns for me, and it'll just give me the sum for every row, as you can see over here. Let's just do that. Now I have an explanation how axes work. You will see that axes 1 equals 2 columns, but if I am collapsing across columns such as sum and mean and all that, it will collapse the columns. Very important here. I'm going to skip all that. Once again, up to you guys to review that. Use sum, there's some functions as such. But now we're going to get to slicing. That's really where the money is at. So I can access my columns as an attribute. which means data frame .8 corresponds to grabbing column 8. You can see that I've done this here. I can also provide it just like I did in dictionaries, right? I'll give it a key of 8, and it'll give me a column 8 here. I have an important comment here, right? If you're accessing values in this sense, whether you give it a row index or column label, Pandas will try to match that and figure out what you're trying to ask for, whether you're grabbing a column or a label. Now, if I'm doing slicing, right, I can do slicing this way. I'll have to use a .lock function for me to do that. So I cannot slice across the columns in this matter. You'll see that I'm getting there, right? But I can do that for my rows. So I'm going to grab row 1 through 5, right? And then it'll grab me rows 1, 2, 3, 4, 1, 2, 3, 4, excluding 5, but not grabbing row 0. Very important here. Once again, a bunch of review here, you know, nothing really crucial. Now, here's the new part, .lock. So I'm gonna, this is called selection by label. So if I do data frame or name of my table, .lock, that would automatically tell Pandas that I'm accessing rows and columns by label, meaning by these values, not by position of it, not row 4, 5, or 6, but the actual label on that row. And the same goes for columns, not column 0, 1, 2, 3, but column A, B, C, D, and so on, right? So, in here, in this sense, let me just print DF so you guys can see that. Here's my initial table. I'm going to say DF, name of my table, .lock, and I am providing, the concept here is first you got to provide the rows, then the columns. If I want to slice the rows, I'm just going to give you the indices for those rows. So I'm going to say January 1st, 2020, and I'm going to slice up to 5th. The difference is here, if I'm slicing by the label, both of these values are inclusive. You can see that I'm grabbing first, January 1st, 2020, and January 5th, 2020. Slightly different than the indices that we used for list slicing, because I'm slicing that by label. If I do not want to define which columns I'm slicing, I'm just going to put semicolon here. That will correspond, grab all the columns for me. All of a sudden I get all the columns. Right? Now I can omit the columns here. If I omit that, I'm just going to get the same result as the one above. You will see over here, I'm just grabbing the rows. Right? I just provided the rows. The general concept here is this: df.lock, start row, finish row, step size, very much like the lists. Comma would imply that now we're addressing the columns. We're going to start at this column, we're going to finish at that column, defined by semicolon, and then over here we're going to define a step size. So there we go, and that's kind of how we get to here. I'm going to slice this and define the columns. I'm going to slice here the rows and omit the columns. That still works. However, going all the way around, that's not going to work. If I do df.location, I give the labels for the columns, I'm getting there. Why? Because I didn't provide the rows. So Pandas is not that flexible in terms of that. Right? If I do want to slice for the columns, I do have to emphasize I want to grab all the rows. So I'm going to say data frame, .lock, location, open up square parentheses, now square brackets. Then I'm going to do semicolon, means grab all the rows there, grab column A by label, right? And then set that to S. Then I'm going to just display that to make it easier. So what I'm doing here with this first statement, I'm just grabbing this entire column. Column A. Once again, to remind you guys, column corresponds to a series. Right, so I define that, and I said this is going to be a series. Then I can do the same deal with the series. I can do slicing and selecting by label location. So now I'm going to say I grabbed column A. Now I want to slice it and select this row with a label 2020 January 1st. And you see I get the value. Okay. If I just want to print, let's do that. Let's run that, and I'm just going to print S. You can see the S this statement equals to column A. It grabs the entire column, and this indices for each row in that column correspond to this indices. And when I slice that again, I'm grabbing this guy right here. As simple as that. Dot lock essentially grabs by the label. So you have to match these labels. A, B, C, D for the columns, and for the rows will be whatever the labels are within the rows. Let's say I'm going to print the head here once again just to get the default for dataframe.head would be 5. You see that? Int 5, that's the default value. So unless you pass it another value, it'll just print first 5 rows. All right, so if I'm going to do that, I'm going to get 5 rows over here. If I'm going to pass it 2, I'm going to print just 2 rows. So now let's say my indices or row labels, right? Row dates. So I don't want to work with that. I want to change it. I'm just going to say df index, which will grab the indices or row values, right? Row indices. And I'm going to set it to a new list. The reason I'm doing that list from a string is it's going to break the string off the list. And all it's done is reset my indices to A, B, C, D, F, G, H. Right, so now things will get a little more complex. Let's say, let's do DF so we can see what the table looks like. Oh, there's no sum. And that's why we're doing that. Let's do B, no work. So let's say now I want to take a slice, right? And I have this table and I just want a row A and D, and I want column A and B. It's done as simple as that. I will pass it the rows that I want, A and D. It has to be a list. You guys once again read the definition. It will tell you what you have to pass it. And you'll see the first thing that comes up. I'm not even going to waste time on that. But essentially, if you want, instead of a slice, if you want to select a list of rows and columns, you have to pass that as a list. So I'm going to pass it a list of rows, A and D, and a list of columns, A and B. So it's not a slice anymore. It's a very specific selection. I select this guy, and this guy, and this column, and this column. So far, we've been selecting by labels, right? The actual names of the columns and the rows. Let's say you don't want to deal with that. Let's say you just say, I want a first row and a fifth column. For you to do an integer location, we're going to use iloc instead of lock. Once again, we've got the df table. Right? Definition is over here, links row attached. I'm going to say df iloc, and a very similar slicing to a list would work. I'm going to start at row 0. I'm going to slice all the way throughout the table in terms of rows. And my step size is going to be 2. So I'm not going to be grabbing A, B, C, D, E. I'm going to grab A, C, E, etc. until the end of the table. Now I'm going to do the same deal with the columns. I'm going to grab column 2 and column 4, or a range of those. One thing to know, dot lock is inclusive. So it's going to include your beginning and the end interval. Dot iloc really corresponds to your list slicing. So we'll exclude your last element. You can see I'm grabbing row 2, 3, but excluding, or column 2, column 3, but not including column 4. So it'll be B and C should be there. Or C and D. 0, 1, 2, that's right, C and D. I'm grabbing these two, right? So very intuitive in terms of lists and slicing data frames, very intuitive. Dot lock will give you the label slicing, so the actual names of the columns and the rows. iloc will correspond to integer slicing, just like we have done on the list. We'll do by position. Matt, what are we looking like in terms of time?
We are coming up at an hour and a half.
Man, okay.
So
tell me what the plan is here, man.
let's do a poll real quick, because we'd like to keep this. Would you like to cover another notebook tonight?
And
We'll
we
just-
can all-
Yes. No, because we know this is going to be a multi-part one.
yeah.
But let's see here. Let's see. I should be able to ask everybody what their preference is. And then we'll let majority rule, and then we'll go from there.
Yeah. Yeah, I'm not gonna say that. Whew, there's a lot.
Okay. So we'll go ahead and we'll wrap it up for this evening, and we'll launch the other section coming up. So what do you guys think? It's a lot of the fundamentals right now, or we'll be getting into the more applied stuff as we go. George, thank you again so much for going over it so far, and I look forward to seeing the rest of it. Let's see here. So another shout out. Thank you again for RMAG, the Members in Transition program, the Crude Audacity Podcast, Sarah Drodowski, CU's GEM program, Josh Turlick, Well Data Labs, Jim Thorson of Free Radical Ventures, Terry Olson. Terry, enjoy retirement. That's pretty awesome. We'll be putting up our next section of Pandas overview here pretty quick. But until then, be excellent to each other, and we'll be chatting with you all again. Take care. Thanks again. Bye.
Yeah.